Hello everyone, welcome to the video. Today we're looking at section 7.7 where we are going to be factoring special products. So it says how can you recognize and factor special products? It's actually, in my personal opinion, easier to factor special products, especially when you know that they're special products, because they're either going to be the sum and difference pattern or they are going to be perfect square trinomials. So if we go back and review, we're basically just looking at those patterns in reverse. So if you notice, if something is a sum and difference pattern, first off, it's going to be a binomial for starters, and both terms are going to be perfect square numbers. So how do you identify what perfect square numbers are? Basically, if you just go down the number line, one squared is one, so one is a perfect square. So two squared is four, so four. Then it's going to be 3 squared, which is 9, 4 squared, which is 16, 25, 36, and so on and so forth. Essentially, if you could take a number and put the square root of it and the result is an integer, it's a perfect square number. So as long as those set up in that style, you should be able to factor out the sum and difference pattern. So the example they gave here is x squared minus 9. So x squared, is that a perfect square? Yes, because you have the 1 and x times x. If you took the square root of x squared, it would be x. So that's why you can write x and x there. And the square root of 9 is 3. So you can put 3 and 3, and you know that they're going to be different signs in the two sets of binomials. If you look at a perfect square trinomial, what you're trying to initially identify is, do you have a perfect square on the outside? Do you have a perfect square with A? Do you have a perfect square with C? And in this case, you do. Now, you can go about factoring out just like you did in 7.5 and 7.6, or you can um, once you notice what it's going to be, figure out what the square root of 9 is and say that, oh, it's going to be x plus 3 quantity squared. You can absolutely write this as x plus 3 times by the quantity of x plus 3. All right, that doesn't bother me. All right, same thing goes for the bottom one. You could say it's x minus 3 times by the quantity of x minus 3. Again, that doesn't bother me. You just have to be able to figure out which method or how you want to be able to solve this and then move forward. So looking at these two, they're two binomials, and you have to ask yourself, are they perfect square numbers? Well, x squared, yes, because square root of x squared is x. Square root of 25 is 5. So when I factor this out, I'm going to go and say that this is going to be x plus 5, and this is going to be x minus 5. You certainly can FOIL this out to see if it comes out to x squared minus 25, and I assure you it does. If I look at b, square root of 4 is 2. Square root of z squared is z. So it's going to be, sorry. It is going to be 2z plus 1 times by the quantity of 2z minus 1, because the square root of 1 is 1. So those are the factored versions of those sum and difference patterns. So here, it wants you to use a special product pattern to evaluate the expression 54 squared minus 48 squared. Now, what you're going to have to do is essentially rewrite this as a sum and difference pattern. So you could say that this is, you could write this as 54 plus 48 times it by the quantity of 54 minus 48. So by doing that, 54 plus 48 is what, 102? And 54 minus 48 is what, 6? And 102 times 6 is 612. So that's what kind of what they want you to notice in that pattern. And again, you can check your solutions by, taking 54 squared and subtracting it by 48 squared. All right, so in these two problems, we have trinomials. So the first one is a simple trinomial because there's no value in front of the lead coefficient. So that means it's 1. What I prefer to do is I just prefer to factor it. So I'm just going to go parentheses, parentheses. It's going to be n and n, same sign plus. What two values give me a product of 16 and their sum is 8? It's 4 and 4 because 4 times 4 is 16, 4 plus 4 is 8. They just so happen to be the exact same thing. You can leave it like that, or you can write it as n plus 4 quantity squared. This and this are acceptable answers. If you look at B, same thing. It makes it, much more easier to, because you're in a section that's telling you that it's special product. So yes, 4 is a perfect square number. Yes, 9 is a perfect square number. They're going to be the same sign and minus. So obviously, not obviously, but um, they're going to be the same thing, whatever it is inside the parentheses. So square root of 4x squared is 2x. So 2x would go here. They're both going to be minus. Square root of 9 is 3. All right, let's double check. 2 times 3 is 6. 3 times 2 is 6. Do their sums give me 12? Yes, they do. So you can say that this is my factored out polynomial. You can easily write this as 2x minus 3 quantity squared. Here we have fractions. You might be thinking like, well, how are we supposed to solve this? But think about it as the numbers as each individual numerator and denominator, and it makes a little bit more sense. Well, it is in fact a simple trinomial because a is 1. So if I go about setting this up, it's going to be x and x, same sign, plus. So I got plus here and plus here. It's an equation. It's set equal to 0. We're already good there. What is the square root of 1/9? Well, what's the square root of 1? Well, that's 1. What's the square root of 9? That's 3. So you have to ask yourself, is 1/3 times 1/3 1/9? And yes, it is. So now you have to ask yourself, is 1/3 plus 1/3 2/3? And the answer is yes. They are the same, so I can write this as x plus 1/3 quantity squared, but it is an equation and it's set equal to 0. So now all I have to do is take just one set of x plus 1/3 set equal to 0. I subtract 1/3 from both sides. So my answer for x is going to be a negative 1/3. All right. Here it says a bird picks up a golf ball and drops it while flying. The function represents the height y in feet of the golf ball t seconds after it is dropped. The ball hits the top of a 32-foot pine tree. After how many seconds does the ball hit the tree? The ball hits the top of the 32 tall pine tree. After how many seconds does the ball hit the tree? So they give us an equation here of y equals 81 minus 16 t squared. So they're telling us that y represents the height in feet of the golf ball t seconds after it is dropped. So y is the height. They're telling us here they want you to figure out the ball hits the top of a 32-foot tree. It says how many seconds does it take for the ball to hit the tree. So y is going to be 32. So I can write here and say, okay, I got 32 is equal to 81 minus 16t squared. All right, so what you got to do is, well, first, I prefer I prefer to have my lead coefficient to be positive. So let's do this. Let's add 16t squared and let's subtract 81 from both sides. So it's going to be plus 16t squared minus 81. So when we do that, these get canceled and I'm left with 0 over here. Now I have 16t squared minus, that'd be what, 49? Hold on a second, 132 minus 81. Yeah, so it would be minus 49. So now here, I can factor this out. It appears to be a sum and difference pattern because 16 is a perfect square, so is 49. So I can say that this is going to be 4t plus 7 times by the quantity of 4t minus 7. Set that equal to 0. Using zero product property, in this case, t is going to be a negative 7 over 4. And this one here, t is going to be a positive 7 over 4. So, because time can't be negative, can't use that t, so the only one that works is 7/4. So, and I believe it was in seconds, so it's going to be 7/4 seconds, or you could write it as a decimal. In this case, it would be what? 1.75 seconds. And that is being able to factor special products. Hope this helps. Until next time.